Okay, so for Unit 5 and 6, this is the last little video. Unit 5 is about electron configuration. Remember, we learned about electron configuration, which is going to look like this. Okay, so it's about knowing your different parts of your periodic table. You had orbital notation, which was the one with the arrows. Okay, and then you had your dot notation. Oh, we had noble gas as well. We'll go over that when we get down to that question. But you had your dot notation where you actually look at what group number they're in. Okay. Before we answer the questions, just because I think I left it off of your guys' little review, use that little space above right here and talk about your orbital notation real quick. Okay, so just give yourself 2 lines and then do 3 like that. Okay, give yourself that. So this is 1s, this is 2s, this is 2p. Okay, just to remind ourselves how to fill these up. Okay, so when you go to fill these up, remember it's just like filling up the floors in that POGL that we did. Okay, you fill up your first floor first. So you have somebody on the bottom bunk or top bunk, bottom bunk. Okay, then you move to the second floor. You're still in the S block. So you're going to do your top bunk, bottom bunk. When you get to the P or the pink rooms, right? What did you have to do? Can I just go like this?
No, you have to fill up all of the bunks.
Right, we have to fill up one of the bunks first, okay? One part of the bunks in all of them, okay? So when you go across 2P, so if I had something that was 2P5, like fluorine earlier in the other video, okay? We would say 1, 2, 3, and then start flipping them. 4, 5. That would be appropriate. Any other way is not okay. Okay?
Unless it's excited to.
So the element with electron configuration 1s2, 2s2, 2p6, 3s2, 3p6, 3d2, 4s2. All right, real quick, just because I told you guys this is more expected for the AP guys, okay? What did you guys learn? What's different in this? Right. In your periodic table, 4s comes before 3d, right? But when we're talking about the energy levels or those layers, the 3d is going to be on the inside of 4s, and that's why it jumps around like that, okay? So, good. All right, so for this one, you would look at the little shortcut here is you look at whoever your last guy is. You make sure everything else is filled. So 2, 2, 6, 2, 6, 2. And you look at your last one. And you go find that guy on your periodic table. That's the shortcut on these, okay? So we want 3D. So we're starting right here. And we want to go 2. 1, 2. Okay? And that's your answer. Okay? Just a reminder, though, just in case you're asked to write it. When you guys do it, you would have gone 1s2, 2s2, 2p6, 3s2, 3p6, you got the idea, 4s2, 3d2. All right, that's where that's coming from. So you're just following your periodic table across, okay? So don't forget the basics there. All right, so your answer here, A. When you are doing your noble gas notation, that is where you check the row above. So let's just say I was trying to find this guy. You would check the row above, use that in your noble gas, or the little brackets, and then you would start here and continue your electron configuration. So it would be 5s2, 4d, whatever that is, 10, yeah. Okay? So when we look at the question they gave you, they want to know vanadium. Okay, so vanadium.
Okay.
All right, so we're looking for vanadium, okay, and when you're doing your noble gas, we're going to go up a row ahead. We're going to throw argon into the brackets, and then we're going to start here, okay? So we're going to say argon in the brackets, and then we go 4s2, 3d, what? 3. Good. So your answer is this one. Remember, once again, it's just written in AP form. Sorry.
Wait, so then which was the right answer?
It's A.
Wait, why is it D? So you want it?
Oh, A or D. A or D. I'm sorry. I didn't realize they were that way. You guys, this is what's going to be expected of you. You guys are going to do this one. Don't worry. Okay? Sorry. That was... Anyway, I don't have to explain myself. All right, 21. Atoms have the electron dot notation shown at the right would most likely be located in what group? All right, so what should you do with those? Count them up, right? So how many dots are there? 6. So since there are 6 dots, do we want periods? No, those are horizontal, so we want group 16, okay? All right, 22. So this guy, this is fluorine, so we're going to say he's in group what? Group 17. So he's going to look like fluorine right there, and then we're going to take our dots. We're going to go 1, 2, 3, 4, 5, 6, 7. And that would have been the right answer. So none of the above. Ignore those. All right. Okay. We're on our last little stretch, you guys. So flip the page.
Are they not doing the pledge today?
Okay. So for this one, periodic table and trends, this was our last unit that we covered. So I want you to draw just a little periodic table right here, or a little square. Put big heart, little heart, put B and a little S, little s, okay? And we remember your trend going across is always what? Zeph, or effective nuclear charge. Remember, that's protons. Okay? Your argument going down is always shielding. Good. Okay, so adding on layers makes radius get bigger. Coulomb's law states that more distance means less force, and more force from the inside, or more protons, means more force to those electrons. Okay? All right. So, letter B, a potassium atom is larger than a potassium ion. Why? What does the potassium ion look like? He's a cation, so it would be, and he's in group 1. Right. So it lost an electron, so more protons. More protons. He has more protons than he has electrons now. If he gives one away, he's more positive. So that's more of a pull. You get smaller. Yeah. Sorry. So what I'm describing here is the potassium ion has more protons. Okay? It lost an electron. All right. The ionic radius of S minus 2 is larger than that of Cl minus. What should stand out to you here? Which one gained more electrons? S. Okay? So S2 minus gained 2 electrons. It's sulfur's anion. Okay? Okay, which is big. Gobbled up 2 more electrons. All right. 1 to 3 refer to the following elements. So who has the highest electronegativity? Electronegativity is what trend? Radius or heart? Heart. Okay, so looking at your little picture that you just drew at the top, okay, who has the highest electronegativity out of those guys? No. BR. Okay, so remember, one thing about electronegativity, it doesn't for noble gases. Noble gases have the high ionization energy, but they're not going to bond, so electronegativity doesn't really matter to them. Okay? Electronegativity is about attracting those electrons. Okay? In a bond. Okay, so bromine. All right. Reacts explosively in water.
That's going to be the alkaline.
Mm-hmm. So who's in group 1? Potassium. Okay, your alkali metals. All right, who has the largest electron affinity? Again, this is the heart one. We're probably not going to ask you about affinity. We'd ask you about ionization energy or something. But who has the largest electron affinity? Should be bromine again. Okay. All right. Down here, skip down to D, and then I'll come back up to E if we have a second. All right. So D is the first ionization energy of aluminum is less than the ionization energy of magnesium. So find them on your periodic table. Okay? If you notice, aluminum is right here, right? Magnesium is in the same row, but all the way over here. Why is aluminum... You guys are not going to get tested over this. Okay. But what it has to do with, really quick, where is magnesium? Which block, what sub-level is it? S, right? So this is actually 3s2. What does aluminum start? 3p1. It is easier to steal that person out of their bunk bed than it is when there's another person witnessing. I am. That's all on the video. All right. But basically, when you have an unfilled bunk bed, that's easier to take away than it is when there's two. All right. So a full thing is stable. Not full thing is unstable. It's easier. Okay. You will not be tested over that. That's kind of AP level, as well as E. E is talking about why this trend is happening. And what it has to do with is the fact that your guys' little equation for Coulomb's law that you learned was KQQ over D squared. It's that. It's the fact that this little graph goes like that. So the first couple jumps, I'm sorry, I put that graph backwards. It should be this. This is the graph. So it's big jumps at first, and then it levels out, so it's not as big of a jump. You guys are not going to be asked that as well, okay? So you guys are good. So that's it for your benchmark review. No, it's not. Just kidding. Dang it. We have one more thing. Okay, at the bottom. We're going to do this quick. What group on the periodic table are most reactive metals? Alkali. So group 1. Okay, alkali metals. Why? Yep. So they just need to lose one electron. So they're super reactive, just like our halogens are our non-metals that are most reactive because they just need to gain one. Okay? In group 15, give the symbols for the non-metals. So look at group 15 with me. Nitrogen, phosphorus, and semi-metal. I can't read the rest of my... okay. Arsenic, right? Arsenic, antimony, and then finally bismuth. There you guys go. Okay, which one has the smallest radius? We're looking in top right corner. It would be sulfur. Yep. Sulfur has one energy level less than bromine. Bromine would follow close behind, though. All right. Which set lists the elements in group 1 in order of increasing electronegativity? Just so you know, shielding effect always trumps the Zeph thing. So if you have an extra layer, that always trumps whatever else you've got. Okay? All right. So which set lists them in order of increasing electronegativity? So that means going to the top right corner. Okay? So we got... I'm going to let you guys figure that one out. All right, the answer here is going to be B. We're moving up the group. All right, good.
Great, now we're done.
Okay, make sure you study, please.